Welcome to my YouTube channel, Passionate Piping Engineer. In this video, we are going to learn about what is pipe and fundamentals of pipe. In previous video, Introduction to Process Piping, we have seen all the piping components such as pipes, tubes, pipe fittings, etc., which are used to complete a piping system, but we have not studied them in detail. From this video onwards, we will learn all these piping components one by one and try to understand them in a detailed manner. So let's begin the journey by our first and most important component, that is pipe. In this video, we are going to learn on the following topics. First, we will learn what is pipe, followed by pipe categories, pipe sizes, pipe lengths, pipe construction methods, pipe materials, pipe end preparations, their common end abbreviations, and last but not the least, dimensional standards for pipes. So let's start with what is pipe. Pipe is a hollow cylindrical section for transportation of fluids and gases from one place to other. The cross section figure clarifies this. Or we can say that a pipe is a pressure tight cylinder used to convey fluids under pressure from point A to point B as shown in the figure. Tank A and tank B are the 2 points and it is connected by pipes through which the fluid is flowing. Second topic is pipe categories. Pipes are divided into two major categories. First is small bore pipes and second is large bore pipes. Small bore pipes. Small bore pipes are usually pipes that comes under a size range of 0.5 inch NPS to 1.5 inch NPS. That is nominal pipe size to 1.5 inch NPS. Only plain end pipes are required for joining two small bore pipes, and it is joined by means of a full coupling as shown in the figure of the cross sectional view, a union joint and a flange joint. Fittings used for small bore pipes are socket welded forge fittings. Dimensional standard for socket welded forge fittings is ASME 16.11. 1.5 mm gap is given at the time of welding. The pipe is first inserted into the socket of the socket welded fitting, then it should be lifted by 1.5 mm, then welded by means of a fillet weld. Minimum thickness is used to minimize deflection for carbon steel material SCH80 or bending, whereas for stainless steel material, that is SS material, SCH40S can be used. What is SCH? SCH is an abbreviation to schedule and refers to a wall thickness. As the schedule increases, the wall thickness increases and the inside diameter is reduced. Selection criteria of the small bore pipes depends on the schedule and the pipe ratings of a pipe. Pressure rating of a pipe is a maximum allowable working pressure. It is actually the ability of the pipe to resist the internal pressure, and it is defined by a pipe schedule or a wall thickness. Selection criteria for small bore pipe fittings, that is socket welded fittings with reference to the pipe schedule, are as per the below table. If we see this table, there are two columns. First shows the pipe schedule number and second shows the rating for socket welded fittings. Now, up to pipe schedule number 80, the rating for socket welded fitting is 3000 pounds or rating or LBS. Above schedule number 80, up to schedule 160, that is extra strong, we have rating for socket welded fitting is 6000 ratings. Above schedule 160, extra strong to double extra strong is 9000 pounds. There is one question which is very frequently asked in the interviews: why socket welded fittings are not used in the main process line of food and pharmaceutical industries. If you look at the cross-sectional view, in the adjacent figure, there is an approx 1.5 mm gap when the pipe is inserted in the socket of the socket welded fitting. And because of this, the fluid flowing in the system gets stagnant in this gap, causing corrosion which affects the quality of the final product. Hence, socket welded joints are not used in the main process line of food and pharmaceutical industries. But why is this 1.5 mm gap needed? Like I said earlier, when welding the pipe, it is first inserted into the socket of the socket welded fitting till the end, and then it should be lifted by 1.5 mm. Then the pipe is welded by means of fillet weld. This is done to prevent heat expansion of joint welding procedure. That is, expansion joint to prevent weld from cracking under thermal stresses. Second pipe in this category we have large bore pipes. Large bore pipes. Large bore pipes are usually pipe that comes under size range of 2-inch NPS and above. Only bevel-ended pipes are required for joining two large bore pipes, and it is joined by means of a butt welding as shown in the figure of cross-sectional view of a butt welded joint. Fitting used for joining large bore pipes are butt welded broad fittings. Broad fittings are fittings made of pipes. Broad fittings are available seamless and welded in market. Dimensional standard for broad fittings are ASME B 16.9. When it comes to thickness, the thickness of the broad fittings are same as that of pipe fittings. Minimum thickness used to minimize deflection or to make support economical. Selection criteria for large bore pipes and pipes fittings, that is butt welded fittings with reference to the pipe schedule, are as per the table below. We have two tables here, first for carbon steel and second for stainless steel. First we will look for carbon steel. Carbon steel, we have schedule range of 2-inch to 6-inch NPS, we have schedule 40. 8-inch to 14-inch NPS, we have schedule 20. And 16-inch NPS and above, we have schedule 10. Similarly, for stainless steel, we have 2-inch size range from 2-inch NPS to 6-inch NPS, we have schedule number schedule 20S. 8-inch NPS to 14-inch NPS, we have schedule 10S. And 16-inch NPS and above, we have schedule 5S. Third topic in our list is pipe sizes. Pipe sizes are designated, or we can say specified, by two non-dimensional numbers. First, by the diameter, that is an inch. It is nominal pipe size. We can say it as NPS. For example, 3-inch NPS and 6-inch NPS, and so on. Whereas in metric system, it is DN, nominal diameter, or NB, nominal bore. And second by the thickness, that is by schedule, SCH. NPS is a dimensionless designator of the pipe in an inch and is near to the ID of the pipe. Although the NPS is very closely related to the inside diameter in inches, but only for NPS 1 by 8 inch to 12 inch NPS. In other words, line size up to 12 inch NPS is near to the pipe ID. Whereas from 14-inch NPS and above, the NPS is equal to the outside diameter in inches. In other words, line size 14-inch and above, pipe NPS is equal to the pipe OD. Schedule represents the thickness of the pipe. It is expressed in numbers such as 5, 5S, 10, 10S, 40, 40S, and so on. Higher the schedule number, more is the thickness of the pipe. The OD of the pipe is fixed or constrained, and as per the wall thickness, ID, that is the inside diameter, varies. This table on the screen shows the list of all the pipes up to 24-inch NPS. First column shows the NPS, that is nominal pipe size, which is in inch. Second column shows the nominal bore, that is NB, which is in metric unit system. And third column shows the outside diameter, which is in mm. While working in piping layout and design department, for a draftsman to the designers to and engineers, this table has to be thorough on the tongue, means it must be by heart. Let's see one example how this table works, how to read this table. If you are looking for a pipe NPS, nominal pipe size of 2-inch NPS, its nominal bore means NB is 50 NB in metric system. And in third column, we will get the exact size of the OD, that is outside diameter, which is 60.3 mm. Only up to 12-inch NPS line size we need to be by heart, the OD of the pipe and the above. 14-inch NPS line size, we can directly convert the line size into the inches to 1 millimeters by multiplying it by 25.4. Let's see one example of the above statement, that is, if we see 14-inch NPS and it converts it to OD, that is multiplying it by 25.4 mm, we will get 355.6 mm, which is the outside diameter of 14-inch NPS pipe. Here there are two notes which has to be remembered. First is up to 12-inch NPS pipe is near to the pipe ID, as we have seen. And second is 14-inch NPS and above pipe is near to the pipe OD. After pipe sizes, the next topic is pipe length. Pipe length. Some standard pipe length available means readily available in the markets are single random length, that is SRL, with 6 meter or 16 feet to 20 feet length. Double random length, that is DRL, with 12 meter or we can say 34 feet to 40 feet length. Other customized pipe lengths can also be manufactured, but only on the special requirements of the client and special orders. Let's move to our next topic, that is pipe constructions. Pipe are constructed in two types. First is welded and second is seamless. Welded pipes are further divided into two types. First is electrical resistant weld, that is ERW, or electrical fusion weld, that is EFW. And second is submerged arc weld, that is SAW. Submerged arc welds are further divided into two types. First is straight saw, that is submerged arc weld. Second is helical or spiral submerged arc weld. Helical or spiral submerged arc weld are further divided into two types. That is, first is single seam, second is double seam. Now let us see all these pipe construction methods and try to understand them one by one. First, in welded type, we have electrical resistant weld, that is ERW, or electrical fusion weld, that is EFW. So let us see what are they and how pipes are constructed by this method. So first is electrical resistant weld, ERW. An electrical resistant weld pipe is manufactured by rolling the metal sheets and then it is welded longitudinally across its length, forming butt welded joint. In addition to this, welded portion is heat treated so that the seam is less visible. No additional material means no filler material is used during electrical resistant weld process. Joint efficiency of electrical resistant weld pipes are 0.85%. ERW pipes, that is electrical resistant weld pipes, are usually used in low or medium pressure and general services like water, air, etc. Second one is electrical fusion weld, that is EFW. An electrical fusion weld pipe is manufactured by rolling the metal sheets and then it is welded longitudinally wherein colossus is produced in the form of a tube by manually or automatic arc weld. Additional filler material is added during welding process. Here it is added. Here the joint efficiency is 0.95%, which is higher than the ERW pipes. EFW pipes are used for high pressure and temperature surfaces except in hazardous fluids. Second welded type of pipes we have submerged arc weld, that is SAW. In this type also we have two types. First one is straight saw and second is helical or spring saw. First we will see how the submerged arc weld is done. In submerged arc weld, collagen is produced by heating an electric arc or arcs between the bare plate, electrode and the pipe. It is a welding process where an arc is formed between one or more continuous cored metal electrodes and the work. Pressure is not used at the time of welding, and the filler material is obtained from electrode, that is an supplementary welding wire. The first method in submerged arc weld is straight saw. In this method, pipe is formed by longitudinal butt welding by single or double pass, one of which is from inside. In straight saw, we have single or and double arc welding. The second method of submerged arc weld is helical or spring submerged arc welding. Here the pipe is formed by twisting strips of metal sheets into a spiral shape and then welding the edges where they join one another to form a seam. Single arc weld and double arc weld pipes are available in the method. Submerged arc welded pipes are used where low pressure services are needed due to its thin wall and where the long lengths are required. Second type of pipes we have is seamless pipes. Here the pipe is not formed by welding process, but it is formed by pressing the billet followed by rolling or drawing or by doing both to the desired length. Pipes are finished to dimensional and wall thickness specification in sizes up to 26-inch OD. They are produced in both single random, that is SRL, and double random DRL lengths. Despite of being more expensive to manufacture, seamless pipes provides higher pressure ratings. Joint efficiency of seamless pipes is 1%, that is here they give 100% of the joint efficiency, which is maximum in all constructed pipes. Next topic is pipe materials. Pipe materials we have here is ASTM A106. This specification covers the carbon steel pipes for high temperature services. ASTM A312 standard specification for seamless straight seam welded and cold work welded Atlantic stainless steel pipe that are intended for high temperature and general corrosive services. ASTM A333. This specification covers wall seamless and welded carbon steel, carbon and alloy steel pipes that are intended for use at low temperature service. ASTM A335. This specification covers seamless ferritic alloy stainless steel for high temperature services. The next topic is pipe end preparation. End preparation of pipes. There are three types of end preparation of pipes. That means the pipes are manufactured by three types of end preparations. First is bevel end, second is plain end, and third is threaded end. Bevel end pipes. Pipe end is not at right angle, that is, it is not perpendicular as we can see in the figure, but it is at a standard angle of 30 degree. It can be plus or minus 5 degree, but it cannot be less than 30 degree. Why we need to bevel the ends? This is because beveling of the pipe ends affects the quality of the welding, so that the proper pipe penetration ensures the best possible but weld joint. Beveled ends are implemented for sizes about 2-inch NPS of pipes, butt welded fittings and flanges. Pipes, fittings and flanges are directly welded to each other with a small gap of 1.5 mm to 2 mm. This gap is given for addition of the filler material during the welding process. Second type of the pipe end preparation is we have plain end, that is PE. Plain end is cut at right angle, that is it is perpendicular as we can see in the figure. Plain end pipes are generally used for small diameter pipes up to 1.5 inch NPS. Actually, as per the standards, up to 4-inch NPS also we can use, but it is also based on the economy and the client's requirement. Plain end pipes are joined by socket welded couplings, socket welded fittings, socket welded flanges, and in addition to this, it can be used in combination with slip on flanges also. Threaded ends. Tapered grooves or V threads are cut at the ends of the pipe run, as we can see in the figure. Threaded end pipes are normally used for small diameter pipes up to 1.5-inch NPS. Actually, as per standard, like in plain end pipes, 4-inch NPS we can be used based on the economy and the client requirement. Threaded end pipes are joined by threaded couplings, threaded fittings, and threaded flanges. Next topic which we have in our list is common end abbreviations. Common end abbreviations. Bevel end abbreviations which are used for butt welded pipes and fittings are as follows. Bevel end, BE. As we saw, beveling or beveled ends means machining the pipe ends by cutting the material in order to get an angle on the pipe edges. This angle is needed to get a good weld end preparation. Very common bevel angles are 30 degree plus or minus 5 degree, as we have spoken earlier. Bevel both ends, that is BBE, means both the ends of the pipe or fittings are so formed to be butt welded. Bevel large end PLE means the pipe fittings are so formed to be butt welded but only on the large end, not on the small end. Bevel one end, that is BOE, means the pipe or fittings are so formed that the butt welding is only done only on one end. Bevel small end, BAC, means the pipe fittings are so formed to be butt welded but only on the small end, not on the large end. Bevel for welding, BFW, means the end is so formed means it is beveled for welding. Plain end abbreviations that are used for socket welded fittings are as follows. Plain end. Plain end means machining the pipe ends by cutting the material with the straight edges, that is by keeping the cutting tool perpendicular to the pipe run. Plain end pipes are formed in order to connect two small bore pipes with socket welded fittings by means of a fillet weld, which is right angle weld. Rest all the abbreviations is used in the bevel end pipes, and the logic is same for plain end pipes. Plain both ends, that is PBE. Plain large ends, that is PLE. Plain small ends, that is PSE. Plain one end, that is POE. Threaded end abbreviations that are used for threaded or screwed fittings are as follows. Threaded ends, TE. Threaded end pipes are machining a pipe end by cutting a male V-threaded, usually NPT, national pipe thread, on the end of the pipe, connect the female threads fittings. Rest all the abbreviation used in the bevel and the plain end pipes, and the logic is same for threaded fittings. Threaded both ends, that is TBE. Threaded small end, that is TSE. Threaded one end, that is TOE. Threaded only, that is TO. Threaded per inch, that is TPI. Last topic in our list and the last topic of our video is dimensional standard of the pipes is ASME 36.10 is welded and seamless wrought steel pipes, is carbon steel pipes, and ASME 36.19 is authentic stainless steel pipes, SS pipes. I hope you have understood the topic of this video, as I have tried to break down all the fundamentals of the pipe, right from what is pipe to its sizes, its length, how it is constructed by welding, common abbreviations, its dimensional standards. And thanks for watching this video. In the next upcoming videos, we will learn about the pipe, more piping components. Till then, stay tuned. And yes, don't forget to like and share, because sharing also increases our own knowledge. And don't forget to subscribe to our channel Passionate Piping Engineers to get the latest update and notifications of our latest videos. Please press the bell icon below.